Should I mute myself? I think this should be good now, hopefully. Yeah, so yesterday we had two workshops, the one that I gave and also one from Christian Wamba. It was really amazing. I will not say it because I will not do it. I'll mute my Slack. Do not stop forever. Okay. Yeah. So today we have a meetup and we are also going to be doing a workshop towards the end of the day. I'll share more details later. I'll also allow UK share more details about that. But if you'd like to still attend the workshop, we have two happening today after the meetup. One from Dwayne, it's going to be online, and then the other one from Fortune Ikechi from Storyblock is we're going to be having it here. So right, today we have seven talks, seven speakers that will be sharing everything related to JavaScript, and I'm very excited for that. I'm just going to run through like a brief introduction of what Cityjs is, in case you were not here last year. This is the first time you're coming to our event. Exactly what the vision is for Cityjs and what we've done so far this year. So the first slide you see there is like all the speakers that are speaking for this year. We have over 25 speakers for this event. So yeah, that's me. I am Gift Egwenu. I am the regional organizer for Cityjs Lagos. I'm also developer at Cloudflare, and a few other things that I listed. So why are we doing Cityjs? Cityjs is essentially a community event, right? Run by the community, right? I like to think that I'm a community person. That's why I'm doing this event. Two things: we want to bring like growth to the underrepresented communities. So we have Cityjs across different locations: Nigeria, India, Sao Paulo, like different locations. We also want to make it accessible for everyone, right? By having like ease of access through our tickets, or doing free workshops, free meetups. This meetup is free. The workshop that yes, it was also free, and we also want to bring it across to everybody, regardless of where they are. So we expanded this year to Berlin, a few other Belgrade, a few other locations. But yeah, I'm excited that I was able to bring it here because it's really something to have like a close knit of people that are very interested in something, for example, JavaScript, but also bringing them together to also learn network is something that I'm very passionate about. Yeah, so I have gone through this slide. Cityjs, that's Crazy Community Conference. How we started. So the person that started Cityjs is called Aris. Aris is based in London, and how Cityjs actually started was from three different Java were happening in having a lot of people come to the meetups. They decided it would be nice to actually try to do Cityjs done, right? If you couple of years later, I think a year later or 2 years later, decided they would like to have like a world series. So that's why we now started having locations this year, able to do London, Sao Paulo, Athens, Singapore, India, Belgrade, Berlin, and now we're here in Lagos. It's been nice because I have been opportunity to go to London and Berlin. Next year, let's see if we get some people to go there or get more people to come here. Whatever way, we are finding the brand and getting more people within the JavaScript community to come together. We also have one happening in London. I know that a lot of you are Japanese. In case you Japan to London by next year, you can also attend the one we have in London. I think it's for May, 15th of April. So yeah, you can also check that one out. Yeah, the main goal is to support communities worldwide, specifically JavaScript community. So that's what we have event. I would like to bring this to your attention. So we have a code of conduct is on the website. We frown against harassment, discrimination. This is a very inclusive space. So if you come here, we don't we don't accept that here. So if you have experienced anything, please reach out to me or any one of the organizers and reports whatever happened. Yeah. This event is not only run by me. Yes, last year was very intense to by myself, but this time around I have a few people that are helping me. We said that look, I'm sure you've seen her around. Look, is helping us with volunteer coordination. Informal is also our speakers today. She's helping me with the program management. We have Jessica. Jessica is helping with logistics, and then Faith Egwin is our design lead. And then we have our amazing MC. Where is she? UK. Mary Blessing is going to be our MC for today and the main event happening tomorrow. I would like to wrap up by saying thank you to our sponsors. This event would not happen without them. So thank you to sponsors like Cloudflare, Bonage, AWS. Actually, let me say this. Cloudflare is where I work. So yesterday we did a workshop. Bonage is also a both sponsor, and tomorrow, don't miss out because they're going to be doing a very good thing giveaway. So you need to be here tomorrow. Let's see, we have AWS sponsored this event, and we said give a workshop yesterday. Storyblog, Fortune going to be giving a workshop and also speaking. He's from Storyblog. Propel, I'm not sure if we'll have anyone from Propel here, but they'll possibly be here tomorrow. But they are also one of our amazing sponsors. University, they kindly allow us to use their space for our workshop yesterday. So thank you so much to University. Google Dev Library, also a bronze sponsor. Papaya Studio will be working with them tomorrow for live stream, so I don't have to do all this myself tomorrow. And yeah, also to our community partners, really, they helped us a lot with sharing the word, getting people to know about this event. So thank you to everybody who stayed there. And finally, I would like to end with, while you're here listening to the talks, please kindly shout us out on social media. You can use the hashtag Cityjs Lagos. You can follow us on either of these platforms, Twitter, Instagram, those handles. And then finally, this one was added last minute, but in case there's fire, that's the exit. It's written the exit, so everybody don't run here, go there. Okay. So yeah, with that, we're going to kick off the event. I am very, very excited to hand over to our humble MC, UK.
Fine, don't know me at UK. I mean, I wanted to add this. The MC participated towards giveaway.
Of course, everybody.
Thank you, because I'm here to win. All right. Hello, ladies and gentlemen, and it is a great pleasure that I am going to be hosting this event on behalf of Cityjs Lagos organizers. Right? And I'm so honored to be here, and I hope you're excited to be here as well. Are you?
Yes.
Okay, that's not the energy, please. Are you excited to be here? Good. Now we're talking. All right, so without further ado, we're just going to start this event. So once again, welcome to Cityjs Lagos 2023. Can you put a round of applause? All right, awesome. So today, thank you, Gift, again for that wonderful speech, right? And we're just going to kick off the event. Like she said, we have 7 sessions today, and 2 workshops, right? And yeah, sure. So we are going to kickstart this event by introducing our first speaker in the person of Desmond OBC. And Desmond, in this talk today, you'll be learning about the best practices for integrating web assembly. I had to go and research what web assembly is. It's actually a framework. I don't know if anybody knows it, but yeah, it's awesome. It's not JavaScript, right? And he wants to teach you how this framework and JavaScript, right, how you can use it to like build your own project, right? And the possibilities both technologies, right, offer for the future of web. So Please, with a round of applause, welcome to the stage, Desmond Obisi.
Hello everyone. Hello everyone. Why is everyone good? So alright, good morning everyone. My name is Desmond and I'll be speaking with you guys today. We're going to be learning together about web assembly and let's say the future of web assembly and how it will improve web engineering in the coming future. Right? So my name is Desmond. I contribute to open source. I'm an open source engineer. So I'm jobless. So what I do is I contribute to open source projects I like, you know, do community stuff, speak at events, write technical articles as well. So yeah, that's about me. Yeah. So we'll be going over the introduction. So the way the engineers of software has improved plain HTML website. I go to the web, read plain HTML, and over the CSS, then there are web frameworks and the likes of them. So many things have improved in the way we do things on the web, right? And in this presentation, we'll be exploring like what is the future of web engineering and how it's going to look like in the web assembly and the most commonly used web language, which is JavaScript. So yeah, that's what we'll be looking at in this event. So we also like looking at what web assembly is, how it originated, what it does, and all that. So, and the objective of this talk focusing on web assembly on the web because web assembly is a cloud engineering in IoT and blockchain, limits many places. So, but we're focusing more on web assembly on the web. So that's like the main objective of this talk. So let's get into it. So what is web assembly? So web assembly is often abbreviated as WASM, and it's like a binary instruction format designed to be executed within the web browser. So it's like something you compile to, right, that can run in the browser. So let's say, for example, I'm a C++ developer, right, and I want to write something that can run on the web. Right? So I want to write something that can run on the browser. I I write in C++ code, then a WebAssembly compiler for C++ language and compile it to a WebAssembly module. And that WebAssembly module is like binary stuff that browsers understand, computer understand. So you can actually run on the browser. So indirectly run C++ on the browser. So that's like the layman explanation of what WebAssembly is. So it's like a compilation target for a programming languages. For example, C++, C, Rust. These are like the stable ones that I know that people compile to WebAssembly from. I think Python recently and Golang as well. So yeah, so WebAssembly was initially developed by the collaborative effort of Mozilla, Google, Microsoft, all these web vendors, right? They collaboratively like use these tools. So and it's to address like implementation of traditional web programming language JavaScript. So there are a lot of things JavaScript can do, like running all those heavy computational tasks, right? Something like let's say want to do Photoshop on the web. You don't have to beat it up because it involves like heavy graphics. So, right? So that's why you run Photoshop as a native app on your desktop. You don't run it on the web. But with the help of WebAssembly, you can run something like that with near native speed, like the way it is working on your laptop as an application. It will work like that on the web. So some examples are like you're a designer in the house, you use Figma, right? There's Figma app, and there is Figma on the web, and it's nearly the same experience, right? So Figma uses WebAssembly to give you that experience. So that's what WebAssembly is. So looking at the architecture, so you can see this one is not quite there. So you can see the programming languages and the instrument, and then their compilers and follow it. So when you write any programming language, any language that compiles to assembly, so there are actually libraries, different workflows that you can use for each particular language to compile it to the WebAssembly module, and then that module then can run on the browser. It can run on different architecture, different OS, focusing on the browser. So it can run on different browser, which is WebAssembly module. So the technical planning is that it utilizes a binary format which allows for compact representation. Yeah, and enables like developers to write code with data efficient. And it's also like run like just in time compilation. So this is like the basic architecture. So you write in your native language, compile to your assembly module, and the WebAssembly module can run on different architecture, different OS, different browser, wherever. That's like the basic architecture. And yeah, so example of applications built with WebAssembly. So we have application 360 on the web. So I'm talking about so you can run this application 360. I think it's a what is a computer design software, and Figma, the one we use for example, run it on the web, courtesy of WebAssembly. And there's also card web. So for people that are into making designs for environmental designs, buildings and stuff. So they have a AutoCAD web, you can run on the web, courtesy of WebAssembly. Then Google Earth, so the web version of Google Earth also uses WebAssembly. Right? And then the Macamus, what Macamus does, yeah, also runs with WebAssembly. So now WebAssembly like helps this application. So when you're running it on the web, you also like you won't notice the difference between running it on your normal application as a native application and when you run it on the web because they're not written JavaScript actually. Those web stuff, they're not written with React, they are written with all those low level languages, then they are compiled to WebAssembly, which can run it out. So the compilation is not happening on the browser. That's what actually makes performance bad on the browser, right? So the compilation is not happening on the browser. JavaScript is not running on the browser. It's actually compiling on the server somewhere, and then sending the binary instruction to the browser, and which is compiled to a very smaller size and efficient stuff. So it doesn't have to consume enough memory, it doesn't have to take enough space or take enough plenty time to run on the browser. So yeah. So let's talk about the benefits. So I'll mention some of them. It improves performance. So it improves performance in web application. So you can get that near native experience you get when you run native applications. Also get it on the web when you run that same application on the web. Right? Then security. So WebAssembly uses what they call a sandbox environment to do the compilation and everything, right? So and it offers this sense of security. It doesn't have a tool has not been compiled in browser or have access to that particular tool. So you can only have access, the browser can only access it when it's done compiled. So the way it works, the language is written in whatever low level language it is, compiled to WebAssembly. All those things happening like in a sandbox environment, and then when it's done, it means send the binary instruction to the browser. So memory safety. So WebAssembly like also like helps in memory safety for our application. So you don't have to bother about the memory your application needs. Right? Although WebAssembly for now is like a single threaded binary additional targets. So, and they are like working on making it a multi-threaded store so I can run multiple uh, operations. But then, and that's over memory safety. So you don't have to bother about the memory leakage, quite compatibility of you don't have to worry about that. And then native like experience, like I said, you have to when you run those applications on the browser, you experience, you know, like as if you are running it native just a mobile app and stuff. Then interoperability. So what WebAssembly does for us is that we can actually use a lot of languages on the web, right? I can just write my stuff in Rust, and it runs on the web. I don't have to care about Cityjs or JavaScript. I don't have to learn JavaScript. I just have to write my code in Rust, compile it to WebAssembly, and the browser does its thing, right? So, so people from different language background can actually write applications around the browser. So the interoperability, so we can write any language, compile it to WebAssembly, and it runs on the browser. So the next one is like open standard. So if WebAssembly actually follow the open standard, right? It's a open source, has a maintenance, and it's not like a side project. It's something that is being given like much attention, and you don't have to like worry about whether, of course, most applications have vulnerability, but it's not something that is done by the side that we want to see years. So it's actually backed by the PC community. So browser integration. So WebAssembly integrates with like almost all the major browsers. Right? So it's like one of the benefits. All the major browsers, Chrome, Firefox, Edge, name them. Maybe except for the new browsers that are coming out, which I know that in future it was like integrate WebAssembly. The major browsers have WebAssembly integrated on them. Then efficient size. I'm talking about size before. So when you write those heavy backend code combined to WebAssembly, it actually reduces the size. So you don't have to run those heavy size code on your client side, right? So it helps in reducing size of whatever you are creating. So yeah, those are like the benefits. The list is not yet exhausted, but yeah, these are the ones we look at today. Then let's look at the use cases. So the use cases are web development and beyond. So you can use WebAssembly to build like all these rich interactive visualizations and multimedia on the web. Something like a game, something like a 3D or whatever, right? You can use a WebAssembly to achieve that. Then for progressive web application, so you want a web application that acts like a native application, maybe a mobile app or desktop app. But then it's not like actually a native application, right? It's just that everything is compiled to assembly and enables it to run offline, right? So I know some of us here content developers are familiar to yeah, so they web assembly gives that possibility to have your application offline, yeah, and you can run background on the browser. It offers you that native like experience as if it's like a mobile app or a desktop app. So another one is game and multimedia app. So you can now run something like 3D game on the browser, right? You know, of course, you can use JavaScript to write 2D games, or you can even use to write 3D games. But when there's, for example, games like Call of Duty, FIFA, there is not like a web version of it, right? Yeah, it's because those games like use heavy assets, all those 3D stuff, all those real life experience are actually heavy assets that they can't perform well while they are running on the browser if you are using JavaScript only to write all those assets or all those functions. But when you write them in low level language, use WebAssembly, compile it, you can easily and efficiently run them on the browser. I've seen some of my friends that play them on the browser currently, and in the future we expect that you can play any game on the browser in the future. Courtesy of WebAssembly, right? So talk about blockchain and centralized application. So, smart contract, when you say smart contract, one go to Solidity, Viper, and the rest, right? But then those ones they have known vulnerabilities that are very serious, right? And they have like security issues as well. But with WebAssembly, you don't have to like have any fear, any security. You can use WebAssembly to write your smart contract actually. So if you are in the Rust ecosystem, Polkadot ecosystem, Solana, Nia ecosystem, right? You notice most people they use Rust to write a smart contract or Python to access instead of Solidity, right? So for the Ethereum ecosystem, measures on Solidity, Viper, and the rest. So WebAssembly goes like a good use case for blockchain applications, so you can use it right for smart contract, all that. So yeah, also you can use this sandbox execution environment to provide like an extra layer of security for your smart. So let's talk about the future of WebAssembly. So if you go to the WebAssembly for repo, you see like proposals, the ones that are currently being worked on, the ones that are already live, but they're trying to finalize it, the ones that are still in uh, still like putting proposals in place. They are still deliberating whether to work on this or not. And the ones that reject now, they are not to work on them. So some of the upcoming features, like I say, trading, right? So they are trying to add support for trading. You know, it will run concurrent tasks at the same time. So it will be like a multi-threaded environment, run concurrent tasks at the same time. And then garbage collection, if you're familiar with the most of the languages use like garbage collection to free memory when they have run certain tasks. So the garbage collector build those memory after they have run that task so that other tasks that are in the queue, we have enough memory to also take it, right? So they also like one to use that garbage collection into web assembly. So like they have improved memory management and right memory save code. And then multiple memory. So that the proposals add the ability to use multiple memory within a single assembly module. So in the current version, you can create multiple memory, but then that's by splitting a one module into different modules, right? So splitting one module into different modules, or we want a situation whereby just write multiple modules instead of splitting one module into different. So yeah, these are like upcoming features and things we expect in our assembly. And potential integration in VR and AR through WebAssembly, you can help us to see more VR and AR applications on the web. I also see like machine learning algorithm deployed on the web. We are talking about things running on the web now. So in the future, you can see this potential integration. And quantum computing, also like say quantum algorithm that can be deployed in a system on the web, courtesy of WebAssembly. So ecosystem and so these are like want to get started right, using WebAssembly. I want to know like what it's about. Want to get like advanced knowledge. So you can actually check out these tools, framework. Okay, so these are the tools supporting WebAssembly at the moment. C++, assembly script. So for compiling, these tools are M scripting, binary and markup are your go-to. So Quasar Pack is for us, and scripting is basically for C++. And then for debugging, you can use Wasm Time and Wazi. So these are like tools that you can use in the WebAssembly ecosystem. Then for runtime, once you run your WebAssembly code anywhere, you can use Wasm. And for integration to the browser, so they are using WebAssembly JavaScript API. And then the Wasm Gen as well for the integration to the browser. Then for learning resources, so this I attached the link also in my presentation. So these are like a good resource for you to start the WebAssembly official website, the Mozilla Developer Network documentation, and weekly newsletters as well, and online courses because so they have a community forums like community group, they are GitHub organization and Reddit subreddit. And to make the WebAssembly also like the website and showcase jobs that are related to WebAssembly. So you can also go there, have a look of what you can do with WebAssembly, what are people doing with WebAssembly as well. And thank you for your time, and I hope you learned a lot from this presentation.
Thank you so much, Desmond. Please give me a round of applause. So we want to base something.
they are still improving on making it a kind of more shredded in the future. So I'm asking, is it that whenever the system is designed out of the web to integrate it to the web assembly, does it mean that they are streamlining it into fitting into a kind of mode that is easily understandable by the other languages and other streams? And also, I want to ask, is web assembly a kind of like a platform, or is it something like implementation like a web assembly? So like, okay, Flutter is doing something, Flutter web, and this is they are all trying to like create web assembly. So,
Okay, first one, so web assembly is just see it as something you compile to. You write your code in language, say Rust or C++, right? So if I want that code to run on the browser, and once anything to run on the browser, you have to like JavaScript, okay, right? But then you don't want to deal with that kind of stuff. You just want to write your uh, Rust code, and I write the code that compiles to WebAssembly. WebAssembly is like a compilation package. It's a binary format, like a machine language, zeros and ones, right? Okay, so when that code goes, when that function, let's say it's a function, let's say it's an complete function, maybe something like a complete function, you might write your when you want to click a button, let this happen. So you write this function in your compile it to a WebAssembly binary format, and then run it in the browser. So you see that the one you write in JavaScript, maybe it might take 10 seconds to happen. The one you wrote with Rust compiles WebAssembly running on the same browser and take 2 seconds. So that's the then for the second one, I know what that.
yeah. So the second one, I
Okay, is it like an organization?
like, is it like, you mentioned that
Okay,
so I said, is it like you are used to it or like
it's a tool. It's just that a tool to compile it, that compile the can just click link and want to know a tool, not like that application or something.
All right. Thank you so much for that. Because of time, we won't be able to like take another questions. I'm so sorry. All right. So thanks again for the question, and thank you, Desmond, for giving that answer. So you can meet him later, or anybody else who has questions, you can meet Desmond later to like answer your questions, right? So we're not going to be moving on because of time, and our next speaker is Ifoma Imo, and she'll be talking to us about connecting the dots, how JavaScript links objects using the prototype chain. And please put a round of applause for her.
Hello. Hello. You're good. You're good. Can you guys hear me? Yeah. How's everyone doing? Is everybody okay? Hello. Who is not okay? Precious. No precious. Okay. Today I'm going to be talking. That was a mistake. I'm going to be talking about how rendering works in React, and it's going to be an introduction. But I don't think the title does justice to what we'll cover because I'm going to be talking about how components you write, JSX return, gets converted to DOM nodes, that is rather now used to base the screen. Do you guys understand? Okay. So my name is Ifoma Imo. I'm a front-end developer and technical content creator. And I love all things JavaScript, all things JavaScript. You can find me on Twitter at IT_Oma and on YouTube where I make videos explaining the fundamentals of JavaScript. I'm going to start with asking who knows what rendering is in React. Oh no, how many people are React developers? Who knows what rendering is in React? Yes. What's your name? And email. Thank you. Before I prepared the talk, before I started preparing the talk, what I thought rendering was in React is not actually what rendering is. What I found out was that rendering is just React calling your component. Did anybody else? So the way you call, or the way we call function components, that's what React does. Just React calling or invoking your component. React creates, what's it called? Your component, when your component gets called by React, React creates does create element function call. That's how it invokes your component. It returns a virtual representation of the UI. Rendering in React is React describing your components based on the app's current state and props. So rendering is just React calling your components. But rendering is just one part of what we'll be discussing today. Rendering is not painting the browser. Before, when I say, okay, I want to render this component, let's just think it will just render to the browser. That's a different aspect. There's browser rendering. For React, rendering has nothing to do with updating the DOM. That was surprising. So, how do we go from, or how do the components go from the components you write to DOM nodes that React now, because browser now uses to paint things? That's the browser now uses to DOM nodes that the browser uses to update your screen. Sorry, there are three phases: the trigger phase, the render phase, and the commit phase. That's why I said rendering is just one part of what we'll be talking about today. Should I? Okay. So for the trigger phase, there are two things that will make a component render in React. It's either your application is just starting up for the first time, so that the initial render, or there's been a state update. So the parent component or one of its ancestors, a parent state or one of its ancestor state was updated, and then that will cause your app to re-render. For initial rendering, this is the initial render when your application starts up. Your application just launched, so React needs to go through all your components and render it out. It does this by calling create root and passing it the target DOM node, and then calling the render method and passing your root component into it. Sorry. That's the initial phase. For subsequent updates or for re-rendering, re-rendering gets, for subsequent rendering happens when a state update happens, right? So when a component state gets updated, that's what causes a re-render. So either calling step state from use state or dispatch from use reducer. So a re-render can be triggered when the parent state gets updated. So updating your state automatically queues a render. Now, like I said in the beginning, rendering in React is React calling your component. So when React calls your component, a virtual representation of the UI, a plain JavaScript representation of the component is what gets returned. And this is known as the virtual DOM. I'll see the virtual DOM in a minute. This is still the trigger phase. The render phase, like I said, what happens during rendering is React calling your component. We have the initial render and subsequent renders. Initial render, your application just started, so React calls the root component and works its way down the component tree, building a React element tree of what the DOM should look like. So this, during the initial render, like I said, a JavaScript representation of the DOM gets created. The first time it's the initial render, a JavaScript representation of the DOM is created. For subsequent renders, React would call the component whose state triggered the update. When React calls that component, the parent component, if it returns a child component, React will call that child component. If it returns another component, React will call that component until it goes through the entire nested tree. React will recursively render each child component until it gets to the end, and then it figures out what to update the UI with. And then in this stage as well, a new JavaScript representation of the DOM is created as well for subsequent updates. What React does is, or why it does, what React does is it creates a new JavaScript representation of the UI. And then, remember I said this new JavaScript representation of the UI is the virtual DOM. It diffs, it tries to compare the previous render and the new render. It tries to compare the difference between both renders. And that is what it does in the render phase. Now, I mentioned earlier that the plain JavaScript representation, the plain JavaScript object is called the virtual DOM. I heard people call it fiber, but I do not dig deep into that. I'm calling it the virtual DOM. So when a component is invoked, React creates an instance of it and returns a plain JavaScript object describing that component. That plain JavaScript object and its descendants or its children is what make up the virtual DOM. So what is the virtual DOM? It's a lightweight copy of the actual DOM that is created by libraries like React. It is a virtual representation of the UI that is kept in memory, and it's kept in memory and synced with the actual DOM by React reconciliation algorithm. So when a component, or when a parent state gets updated, when a parent state gets updated, when a parent state gets updated, React creates a new virtual representation of that, right? And then the previous render has a virtual representation. It tries to see the difference between both of them, and then it updates the actual DOM, only the part of the UI that's changed. But it doesn't do the updates during the rendering phase. It's not updated during rendering or during the rendering phase. The virtual DOM is instead of manipulating the actual DOM, manipulating the actual DOM is very expensive. So React uses the virtual DOM to reduce the cost that can be incurred from updating the actual DOM every state change. So it does it on the virtual DOM, and then when it finds the part of the UI that requires the update of the part of the actual DOM, it now completes it, but not in the rendering phase. Now, zero mutation, the virtual DOM does not directly mutate data. When the states change, of course, like I said earlier, React creates a new representation of the virtual DOM. So that is what it changes. It creates a new one and then diffs, but it doesn't mutate the previous virtual DOM. Diffing, when a state object changes, React first changes, still the same thing. React first changes the object on the virtual DOM and now uses it to update the actual DOM, but that's in the commit phase, which we're about to get to. After rendering, the next phase is the commit phase. And this phase is where React actually modifies the DOM, where React actually updates the DOM. During initial render, we have initial render and subsequent render. During initial render, React calls the append child DOM API to put the DOM nodes it has created on the screen. Like I said, this is the first render. There hasn't been any updates. So React calls the append child DOM node to put. After creating a virtual representation of the DOM, it now calls the append child DOM node to put what it has created on the real DOM. For subsequent commits, React applies the changes it calculated during the rendering stage. So during the rendering stage, remember that's when it does diffing and reconciliation and all of the calculation. but it doesn't update the DOM during the rendering phase. So during the commit phase, that's when it updates the DOM to match the latest rendering. And it only changes the DOM nodes that were changed, like the updates, it only updates the DOM nodes that were changed. It doesn't change everything else. So if React renders and there's no difference from the current render and the previous render, it does not update the DOM. So after rendering is done, React updates the DOM, and then the browser now goes ahead to paint the screen. I like to talk about the difference between rendering and committing. But I feel I already, was it clear, the difference between rendering and committing? Did you guys understand? If I ask a question, answer me. If you look at me and pretend you're not seeing me, I will come down from here and give you the mic. So did you guys understand, or should I explain again? Because I want to explain the difference between rendering and commit, or render and commit phase. Who said explain again? What's your name? Owen. Eh?
I just take the last part.
Okay, let me know. Now I said during rendering, React does not update the DOM. That one is clear, right? It creates a virtual representation of it creates a plain JavaScript object describing the component, and that's what this thing is confusing me. That's what the virtual DOM is. That one is clear. So during rendering, React does not know. React has to render to know if it needs to update the DOM. Is that one clear? So React will not update the DOM. For every React component has to be rendered. And then after rendering, React now decides, when it goes through everything to see if there are changes, it now decides, or it now figures out if it needs to update the DOM. Is that clear? Yeah. So if the rendering process does not produce any change, React will not update the DOM. But rendering has to happen. The components, everything has to be rendered for React to figure out if it needs to update the DOM. OL. So it's ON. Is it clear? Talk to me after the talk. Okay. Oh, so I have a demo. I have a simple. It's just a simple to-do app. Sorry. So this is a simple to-do app. The app component is rendered in the main.rendered. You hear that? In the main.js class. When I say rendered, I'm still using the terms I was using before. When I told you, when I say rendering, I figured out that what's rendering is not actually what it is. So the app component is rendered in the main.jsx file. And the app component, I have an array of to-do items. The component contains the state, and then it renders a to-do form and a list of to-dos. The to-do list component renders the list of to-dos. So I want to show you that what React does during the rendering stage is just calling your component. That's calling React to create element, and then that returns the virtual DOM. The plain JavaScript object describing the component. So if we don't do this, React calls your component, right? But here I want to call the to-do list component. You can see that here is, I call the component. We're not supposed to do that. React calls your components for you. But I call the component, and this is the to-do list component. It returns this object describing the component. The component renders three children. That is the to-do list. So is this one clear, Owen? Now, like I said earlier, When React renders or re-renders after a state update, it renders the parent component and all the children components. That's not very optimal, right? So if you run into performance issues, there are several ways to solve them, and one of them is memoization. Now, the React documentation explains, or React has 3 APIs for memoization: React.memo, higher function, use memo hook, and use callback. But Docs explains this better. I'll just show you an example of React memo or using React memo. React memo takes a component to memorize. It takes a component and disables rendering. So if the parent of that component renders, React will not re-render the component. That's good. Use memo takes a function and memoizes its return value. So it disables expensive computation unless the dependency array changes. Use callback takes a function and memoizes the function. So it disables function recreation unless the dependency changes as well. So for the use memo hook, we can skip rendering a component if the parent renders. So if the parent is rendered again, we can say, oh, we don't want this component to render because it's just a visual component and it's not doing anything. Its props is not changing. It doesn't need to be re-rendered. You can do that with use memo hook. So again, I have another demo. Or the same demo, sorry. So like I said, app renders a to-do form and a to-do list component. I'm logging app is rendering here, so we know when app is rendering. I want to know the list of components being re-rendered if it is state. So I'm logging that app is rendering here. The to-do list component, if I open it, it renders a to-do item. I'm logging that to-do list is rendering. If I open the to-do item, it's just for each of the to-dos. I'm logging that to-do item is rendering. So to-do item renders a button. The button is just a visual component. It doesn't do anything. Button does not need to be rendered or re-rendered when the state update happens. But let me show you the button. Yeah, button does not need to be re-rendered when the state update happens. So the first time button is rendered, if I update the state, you can see to-do list is rendering, app is rendering, to-do item is rendering, button is rendering. But the to-do item uses the state or has access to the state, to-do list has access to the state, button doesn't need to be re-rendered. If I want to disable re-rendering for button, I just wrap button with the higher order function, the memo or with memo, and then if I refresh for the first time, we see button is rendered. If I update the state, you see to-do item, to-do list, app is rendering, but button is not rendering, right? ON. Okay, so another thing is using the memorization can be expensive, so do not optimize prematurely. Dan Abramov has an article titled Before You Memo that explains alternatives to memorization. And it's a very good read if you want to check it out. It talks about lifting state or moving state. Rules of rendering. Sebastian Markage has a GitHub gist where he explains in a lot of detail the rules of rendering, what should happen during rendering and what should not happen. I just picked out these two. You can check it out as well. The first one is rendering must always be pure. And by pure, I mean giving a particular input, the component should always return the same output, right? Rendering logic should not mutate or change any object. So the rendering logic should not mutate, it should not change any object or variable that existed before it. You should mind its own business. But it can change any object or variable created during rendering. But the one created before it, you should not change it. rendering logic should be predictable. So you should not call math random or based on now because this their values change. You should not call them inside the render logic. Another thing, has anyone noticed that when you log your component to the console, it renders twice, right? So this is something that is good to know. It's React calls each component twice, and it's to detect the functions, impure functions, or components that are breaking those rules, breaking the rendering rules. So that is something that is good to know. Thank you. Like I said, my name is Ikoma Imo. Thank you. So does anyone have any questions? No one. Oh, okay, you're supposed to call. She will ask. Thank you. Sorry.
I'm confused about the when you mentioned that like children, like and children
Yeah, so if a parent state gets updated, right, React would render all the children components, all the nested components, React would re-render them. And it does this because it just needs to be sure that the state of your application's UI your application's UI is always in sync with React state. So if a parent component gets rendered, state gets updated, React will render all the children components until it figures out what to update the done with. Is that your question? Yeah. Next question. It's not that's why I showed you optimization. This is one of them. Also, minimization can be expensive, and I said there are things like lifting state or moving them down. Options, alternatives to using minimization. Minimizing. Any other question?
So we have so just take that one and now.
I think that use memo.
Render the components. No, not use memo. The memo higher other components to tell React not to. Use memo is different. You use memo to avoid creating a use memo, memoizing the value returned from a function. Yeah, so you use memo, the memo higher other function. You wrap, for example, the button with the memo higher other function to avoid and it will not render.
But if already, if you render to a text swing, what has already been rendered, what's site wants to render. So
You're confused what goes.
I'm confused.
Like you did not understand what I said.
Oh, I'm saying this number you said not to read, you render into the virtual doc. Right. But if it's rendered into the virtual doc, and it's already been rendered into the browser, React still knows that this thing is not supposed to be changed.
I'm not sure I get. When React calls your component,
All right. Can you meet her later so that she can? All right. So we have the help over there. So thank you once again for my. Please let's. Great. So I like the engagement. So please let's keep it up, right? Pay attention so you're able to like ask questions, right? Would I say relevant question or meaningful question now? All right, great. So I have a joke. Is it a joke? I have a joke, right? I'm going to ask, why did the computers keep freezing? Why did the computer keep freezing? You will not get it. I don't know, like your sense of humor. But no. So the answer is because left the window open. All right, she got it. Don't worry. It's a dry joke. I'm sorry. All right, great. So, thank you for engaging me. So, we're just going to move forward to the next session, and mm, we have the next person, Pastor Raphael. Great. And Raphael will be talking to us about improving React performance with memoization. Would that be it? Okay, that is okay, great. So please put your hands together for Raphael. You can do better.
Yes, I will prefer to. Hi everybody. Hi. Good. It's still morning, right? Yes. I'm very excited to be here. First of all, I'm not really a fan of using microphones. I think we'll make do with what we have. Yeah. So I noticed that she struggled with pronouncing the word memorization when she was giving the intro to my talk. So I want to extend that challenge to everybody here. I have a little tongue twister that is not going to be on the screen. Okay. So it says, or it goes, memorization makes mastering mind-bending maneuvers meaningful. Okay. I'm going to say it 3 times, right? And anybody that can, that can give it an attempt can indicate. Okay. So it says, memorization makes mastering mind-bending maneuvers meaningful. Memorization makes mastering mind-bending maneuvers meaningful. Even me that I'm reading it, I'm even like struggling to read it. Okay. Memorization makes mastering mind-bending maneuvers meaningful. Can anybody attempt that? Okay. I saw you hand first. Please give it a try. Okay. So you have to like say like 5 times. But that's why the tongue twister. Let's go.
Memorization makes mastery mind bending between the screen.
One more.
Memorization makes mastery mind bending between the screen.
One more.
Memorization makes mastery mind bending between the screen.
I think that was impressive. Can we give you? All right. Yes, my talk is titled Improving React Performance with Memorization. And I think I want to give kudos to whoever arranged the orders of the talk or the schedule of the talk, because it was really, maybe it was random, but whoever arranged the orders was very, very intentional about the talk in general, because rendering is what you have to understand before you can learn how to optimize your app. Okay. Yes. Hi. Hi. Yeah. Is Kelvin here? Is it here? No. Okay. So I know he's one of the speakers for the event, but I saw this tweet like just yesterday, and I said, no, this stuff must go into my slide. Right? Kelvin has been like constantly dragging React developers for like a week now, right? And I've been enjoying it. It's been giving me so much joy. Are there like any Vue devs in the house? If you know Vue or like Vue, can you wave your hands? Okay. I mean, please give them a round of applause. Like the minority here, and it's not easy, right? First of all, I do not like React. I use React, but I do not like React. Ifeoma, gave us a very good and detailed overview of how React rendering works, and our explanation was very fantastic. But at the back of my mind, I was like, all of these just to render something. All of this just to render something. And yes, I'm not saying Vue does it better. I'm not saying Angular or any other framework does it better. But I just do not like the developer experience that I get to experience when I'm using React. Okay. My name is Raphael. I'm a software engineer. Full stack, but for the past couple of months now, I've been majoring on mobile development. I run a startup called mytherapist.ng, and we help Nigerians get access to therapy through our mobile app. And I like to call myself the chief architect of the entire product. And it's a mobile app, and we do not use Flutter for our mobile app. Can anybody guess what we use? React Native, yeah. So I have to write React, right? Yeah, and our website is built with Next.js, right? Even though I vehemently, kick against it, but my team members were React users, and yeah, I had no say in how that would go. If I had any say, we'd definitely be using Next. Yeah, and the thing is, in terms when we talk about React, I see a lot of people, hopping into the React ecosystem just because it's the fancy thing out there. I mean, I'm not saying that's like, but I've like come to talk with a couple of people, and I see that they're using React just because somebody told them you learn HTML, CSS, JavaScript. Sometimes people you skip the JavaScript entirely and jump onto React. Is there any of us like that here? Okay, wow. Fight after. In terms of performance, React is not my best framework. I would say that. And I'm sorry to React lovers. In fact, I'm not sorry. If you're React, so yeah, I'm not sorry at all. React does not give me like the optimization that I want out of the box, right? And with a framework like Vue, I've written Vue, I've used Svelte. Svelte is blazingly fast. There's like literally nothing to worry about. I mean, if you're worried about performance or whatever, right? Your best bet out there is Svelte, and I can defend it any day on my chest. But React is very popular. I use React. I like React. I don't love it, but I use React a lot. And my philosophy is, if you're going to use React, you've got to learn how to use it properly.
you've got to learn how to actually make the best out of it. Okay. It's a framework that has a lot of really massive support in terms of community engagement, in terms of libraries available. In fact, we've got this therapist portal where our therapists do their sessions from, and we use this video SDK called Agora. Is anybody here familiar with Agora? Yes. So we use Agora to power video calls between our therapists and our users. And when you want to build like a really massive project, you've got to look at all of the components of that project before you even start to choose a technology stack. Okay, you've got to look at what is available for that technology and what you would have to build yourself. And the Agora Video SDK was not actively maintained. It was not actively maintained. There was not a lot of updates being made to it. And I looked at the one for React, and there are active contributions on it. There were a lot of people, making contributions and all that and improving it. So I mean, it was a no-brainer. We had to use React just because of that core component. That's because there was support for React better than there was for Vue. You understand? And that was why we chose React for that. So yes, like I said again, if you would use React, you should make sure that you use it well. Now, Performer here as well has mentioned some of the things that entail how React renders the view or paints to the DOM using the virtual DOM. And if you notice, she mentioned a word consistently, which is rendering. React does a lot of rendering. Too many renders, in fact. And one way to avoid that is through memorization. Before we get to memorization, you want to look at unnecessary renders. So this in its own, expensive computations are in every framework or any language. Right? You have to make computations. You have to calculate things. You have to apply logic to your project, right? These are not problems at all, right? But when this comes into play, this will become a bit problematic. Expensive computations, inefficient event handling would become a bottleneck for you if your reminders are too much. Okay? And when people talk about performance, my usual contribution to that is that performance is relative. Performance is relative. There are some projects that you run that the end user does not matter if it works in if it renders in 0.5 seconds or in 0.7 seconds. They don't matter. They don't know the difference between a Vue app and a React app. They do not. But when it comes to large scale applications where there's a lot of logic, there's a lot of traffic, there's a lot of load, there's a lot of resources being delivered from your end to the user end, you want to make sure that this is not a big problem. Right? There is nothing like something being 100% performant. Right? If you use the Chrome web tools, I believe there's a tool in there called Lighthouse. Lighthouse gives you a metric of how well your app is doing in comparison to some factors. Things like SEO, things like. So there's something I think you can find on the story blog. It has to do with core web vitals. Okay, there's something called LCP. There's something called FCP. FCP is first contentful paint, and LCP is largest contentful paint. Now, humans do not necessarily read those metrics, but computers do. Computers do, and SEO is something very, very important nowadays, especially if you're dealing with a product that has to scale to users through search. You have to worry about SEO, and one of the, I will not call it a ranking factor, one of the factors that influence how well or how much Google rates your site is in the performance. Okay, so let's forget about performance for users now. Let's talk about performance for now. Unnecessary renders, as I mentioned, will make both of these a problem if it's not taken care of. And as the former has said already, usually want to use techniques like memorization. Okay, and what is memorization? Memorization, I'm sorry, I was going to define it right here. Somehow that's keep my mind. Now, when you're hearing the word, in fact, when I first heard the word, I was a bit confused. It sounded like memorization, right? It sounds like memorization. But I was wondering, like, what does this word mean? I did my research, I dug in, and all of that. And I found out that it still meant memorization. Why did they remove the R? Was it a typo? Right? Why was the R removed? But yes, I'm pretty sure that whoever started the trend or something meant to write memorization, but forgot the R somewhere. But if you hear the word memorization, just know that it means you just have memorization. That's all it is. Okay? And it's the process of committing something to memory. Saving the value of something could be a component, it could be a function, or it could be a variable or a value. That's what memorization is. Okay? And how does it help? It helps to reduce the render. Very, very obvious. Okay? I would explain why in a little bit. And it helps in optimizing how you pass props to your component. And it also helps in caching expensive computations. Caching is still, memorization in a way. Okay. Now, I will not want to explain all of this because I think they are pretty obvious. So let's go to the next slide. Sorry, hi. Is there a way to come out bottom of the slide being cut off? If that's not possible, it's fine. I think you should just take it some time.
Maybe because we are doing full screen.
It's fine. All right, guys. So now, inbuilt with modern versions of React, at least in functional React, we have three different logics or three different approaches to memorization. The first is using the memo function that comes with React. It's a I order component. Okay, so you put it like this. I will put on this later on. So we have the memo, we have use memo, and we have use callback. Okay, but before I start talking about all three of this, I want to define something that would be a base knowledge for most of us here today. Okay, and at the end of my talk, I'm going to pick like three different people, and I'm going to ask them three different questions. Okay, but the context of the questions generally is to understand, is to know what you understand is the difference between these three methods. Okay, React or memo, use callback, and use memo. Okay, all three of these are very similar because they help you achieve the same thing, but they have different use cases. Okay, so I'm going to call three different people from three different angles. So please listen and may you be blessed. Yes, I want to define something called a pure component. Okay, in React, there's something called a pure component. First of all, I have like a very big issue with how things are named. Okay, I have a very big issue with how things are named. I believe that when you are naming things, you name them to be as close to the literal meaning as possible, right? And when you hear something called a pure component, I think it's close to the literal meaning, but it's not as close as. So maybe like after this section, maybe somebody could like suggest the name for what you can reference a pure component. I'll call somebody else for that as well. Now, a pure component is essentially a component that does not alter the result of what it returns. Say, for example, I'm sorry that is not on my slide here, but I thought it's very important to talk about that before we proceed. Say, for example, you have a greeting component. Okay, you have a greeting component that takes in a name and returns a text like "Hello, name. I don't like Amana." That's like a greeting component. Okay, and what makes that component a pure component is that it doesn't really like when you pass in name, you would get if you pass in to if you pass in to you get hello Tolu, I don't like Amala. Okay. If you pass in Chile, you get hello Chile, I don't like Amala. If you pass in Chibuzo, if you pass in Siroma Chukuma Adekunle, you will get the same result. Who knows who Siroma Chukuma Adekunle is here? You know, those are the real guys. How many times did you do Kumai? Tell me, bro. 2 times. Okay, fair. Okay. Now that's what makes that component a pure component because not much is being done to what you're passing. Okay, it just takes what you're passing, it doesn't alter it in any way, and it gives you the result. And you will get the same result, or you get a similar result. You can predict the result based on exactly what you passed in, right? Now, take example of a time component or something like that that takes in time of the day and tells you what it is. Say, hi XYZ person, this is 3 p.m. Okay, hi XYZ, this is 5 p.m. Now that's a pure component. You can like immediately predict what you will get from it when you pass in a variable or a prop to the what do you call it, to the component. Now that's a pure component. Let's look at the opposite of it, which is an impure component. Okay. After this again, somebody will suggest a name that we can analyze what impure component is. An impure component alters the states of whatever prop that you pass to it and makes it a bit difficult for you to predict what will come out as a result. Okay. Let's say you pass in a number, for example. If you pass in 3 as a number to a variable, and somewhere in that variable, you are updating that 3, or you are multiplying it with something like math or random. Right? If you are multiplying that 3 with a random number, you know that if you call that 3 now, maybe you get 3 times 3, and you get 9 as the output, right? And then you know that you cannot predict what will come out of it because you are altering what happens to that prop. You could pass in that same 3 once again, and you get 55. 3 times what is 55? That's not you cannot go, right? Yeah, there's I mean, so but the point is that you are altering the state of that component. Do you understand? Of the variable that you're passing to it. You are altering it, making it difficult for you to predict what will come out at the end. Okay? That's an impure component. And a pure component is basically a component that you can understand or you can predict what will come out at the end. Is that clear? Okay, so does anybody have like any like better term that we can call a pure component? No, I think it's the opposite, it's the reverse. A predictable component, right? And that works, right? That works for all of us, right? Does anybody have any other suggestion? A direct component and an impure component will have be called indirect component. I don't think it goes like that. It goes for a pure component, but when you want to look at an impure component, I don't think it really goes. But we'll stick with predictable. That's really good. Now, when you have a predictable component or a pure component, it makes sense really to just save it somewhere because it's always almost going to keep it's like always going to keep the same output. So far, the input remains the same, right? So you want to stop React from doing a render. you want to save React, don't worry about this one. The value will remain the same. So far, my variable is the same. Don't worry about it. Just save it somewhere. Don't do this. Don't tear it down from scratch again. Okay, because that's the problem with React. React is down everything from scratch, rebuilds it anytime something happens. It could be you. I mean, normally if you refresh the page, that should be done and everything, but not when you click on a button. Okay, they are telling me I have 4 minutes more, so let's wrap up. Now, the first thing you want to use, or the easiest thing to use when you want to start applying this technique, is to use the memo function. Okay, so you write, how do you use it? You import the memo IRDA component in React. You write your component as usual. Okay, but when you're exporting your component, just wrap it inside this memo. Okay, and when you import it, just import to those. But React automatically does that. Since you wrap this, it doesn't render it. Is that clear? Does anybody get that? Good. Now the next method that you can use is to use the use memo hook. Now this one is a bit tricky. But it's a hook in React that helps optimize the performance of a function by memorizing. I think I put the array for them. By memorizing its results. So if you have like a very big calculation, let's say you are taking in somebody's coordinates, right? And you want to start somebody's location, and you want to calculating the best direction for them to get where they're going. Maybe they're going from Yaba to Ikeja, right? You want to do an expense calculation that will take maybe like 0 points, like 2 MB of RAM. You want to do that calculation once. Pass in any variable that you want to pass in, and then put in what we call dependencies. Okay, so what that means is that we have to save the value of this thing in this variable. It will save the value of this thing, and it will not run this expensive calculation again unless what is here changes. It's as simple as that. Now the next one is use callback. Okay, is use callback. You use callback works similar to use memo, only that use memo saves a value, but use callback saves a function, an entire function. That's the difference between use memo and use callback. And I have like a very summary example here. Time will not let me dig much into it, but I hope that you understand the 3 methods for memorization. And when you want to memorize, okay, you want to make sure that you identify the costly operations and memorize them. Not everything needs to be memorized. Okay, you want to do the ones that are costly, the ones that are big, all that, and memorize them. You want to select your appropriate dependencies, and you want to also balance readability and optimization. Okay, there's performance code and there's readable code, and I'll fight you if your code is not readable. Okay, don't make your PR to do very, very difficult to review. Thank you very much. My socials are here. For any social network you want to put me, my name is Tiafolion. Okay, so on Instagram, Twitter, Facebook, anywhere else that social network, my handle is Tiafolion. Thank you very much.
Thank you so much, Dr. So we'll take just one question. Right? Yeah, he raised his hand first. Yeah, sure.
The 3 people that are on this last night, you guys are lucky.
Yeah. So thank you for the talk. And I have 2 questions actually.
Okay.
So the first question is, when do you start thinking about optimization in your React app? And then the second question is, I want you to answer the question you showed you. So React, because I joined the space with Kelvin now. how would you answer the question if we have to?
Okay. Yeah. So your first question is a very interesting question to me. It's a question I really, really like to answer. Now, the thing is, these things are habits. Okay, putting performance in place is best done when you make it an habit. So I will not tell you to wait until when your app is big and will be used by 5 million people before you start thinking about performance. It's best that even when you're building your to-do apps, build it, right? Build it and all of that. And then when you want to improve it, look for ways. How can I make this more performant? So you understand? And doing that consistently, even for your side project or whatever project you're doing, would help you like have that in you that whatever app you're building, you're already used to making things performant. That's it. So in any way that you can, try to make your apps performant. You don't have to wait until when it's big or not. Now, is React slow? I will not answer that question. You know the answers deep down within you. You React developers know the answers deep down within you. But I mean, for building apps, React is really, really lovely. I will tell you that. React is really, really lovely. It takes away some of the heavy lifting for you. And that's amazing, right? React is not slow. Slow is relative. Compared to Svelte, I will tell you yes, React is slow, right? But for your use, for like general use cases, React is good. React is good. React is fast enough for whatever you want to do. Okay, I mean, I can't think of any app where I would think React will not be good, right? But the thing is, use whatever tooling you like to use. It's not a war. Use whatever tooling you want to use, but when you're using that tooling, make sure that you know how to use it right. Thank you.
Thank you so much, Raphael, and thanks everyone that engaged. Right, I have a question for you, Raphael. Yeah, you say you work with my therapy. I was wondering, do everybody in the room get a therapy? Because 10 people do need that.
Yes, so I mean, if you want we are as my therapist
For free.
and
Okay, discount is nice. All right, please clap for Raphael again. Okay, great. I'm sorry I bored you the first time, but I still have a joke again. All right. What is that joke? How many programmers does it take to make changes to a light bulb? Yes. Huh? Who's answering? Okay, so that is not an action. I don't know why. Because it's a hardware problem. All right, you guys left a view by the window. I'm sorry. All right. So before we move on to the next section, pick up your phones. Real quick, pick up your phone. Your phone. I do not have phones. Don't worry. Cityjs is buy everybody in this house iPhone 15. Hallelujah. Yeah, pick up your phone. Take a picture and post on social media. I have a task to actually make us trend today and tomorrow. So easy. Let's see. Post on social media. You can take pictures of me. Don't worry, I'm fine. Thank you. Yeah, and post. Or you can probably, maybe any takeaway from any of the session and yeah, use the hashtag Cityjs Lagos. I'm not seeing our phones. So if you don't have phone in your house, who would like to borrow my own phone? Nobody. What's your phone? Have you posted today? No. Okay. Then I have gift for us. And for the person that answered Raphael's question, I can't remember who, but who is that? Raphael asked the question and somebody here answered it. He has left. But his stuff there. Okay, please, when he comes back, he has a gift. We have a few gifts for us today. So please engage so you can win something. So yeah, we are already running out of time. So we should again. Are you asking for our hashtag?
Hashtag Cityjs Lagos.
Thank you. That was really loud. All right. How are you doing that? You can take pictures of the person beside you. Hello. We're also here to network, right? So say hi to the person next to you. Take pictures with them. Ask them for their Twitter handle. Tag them. Tag CTJS conference and use the hashtag. Let's know that you are here. The person stepping at the back, please, I should show you that picture, unless your phone will burn. I thought so. You have to zoom in. All right, cool. So while we are doing that, I'm just going to introduce our speaker. If you can hear me, clap one. If you cannot hear me, you can hear me, clap two. Nice. So I want to draw our attention. Thank you. So we have our next speaker, and that's like the last session we'll be having before we go on a very, very short break. Right? So our next speaker is Oyedepo Elizabeth, and today she's going to be talking to us about securing JavaScript application, best practices for urban services. Please, with a round of applause.
Hello. Good day, everyone. My name is Elizabeth Benefit. I am a content developer. I don't know if you can hear me. My voice.
I hear you.
Okay. Okay, I'll be talking about the best practices for securing JavaScript applications. First, again, your first line of action is going to means to protect your home from intruders, thieves, or unwanted visitors. So you're going to take some measures like installing stocks, setting up an alarm system or a camera just to keep an eye on your property and for your own safety. Regarding your is used to protect your web, and that uses JavaScript as a core component for security threats. What are these security threats? The security scripting attacks, site request forgery, injection attacks, and I'm going to explain each one of this. Now, the cross-site attacks is security vulnerability that occurs when an attacker injects malicious script into your web content. If you have, let's say, in a public chat room where different users, anonymous users, can send messages for others to see, and a mischievous public that wants to do a harm chat or just wants to play a mischievous message similar to messages, the malicious messages that have been sent by the mischievous users will be seen by everyone on that public chat room. There are different types of cross-site scripting attacks. There's the reflected XSS, there's a stored XSS, and there's a DOM-based XSS. The reflected XSS occurs when malicious scripts are being sent with current HTTP requests. And probably when this data is being sent with via the current HTTP requests, it's not being processed or analyzed, it's sent in an unsafe way, and an attacker injects a malicious script into this request. I am going to try to explain it, break it down in simple terms. Okay, if you are probably what would I use? I don't know what career path, a software developer, backend, front-end, that is probably looking for books to boost your career growth. Maybe you're looking for JavaScript books or whatever books, whatever language you're writing, and then you visit a book app online, and you visit the book app online. When you visit the book app, you visit probably as an anonymous user. Your details are not registered yet on the. You're going to see most career books, relationship books, novels before you register details. Now, the first visit, get requests is being made to the server's database to show you all the books the book app has available for you. Now, once that get request is being made, if the response that is being sent back to the DOM is in an unsafe way, an attacker can inject malicious code or a malicious script or a malicious content into the information that is being sent, and that information can that script can run on the DOM and get whatever information it needs from that DOM. I think this particular type of SSS, I know. This particular type of SSS attack is very minimal, considering that the users may or may not be logged in. So the attacker gets probably a little amount of information or a very serious amount of information that can be critical to the user and to the app. Okay, the stored SSS attacks is mainly on the server side. It happens when the data comes from the server side and it's not being processed. Like it's an attack that occurs on the okay, in terms, let's assume there's a blog that users go to read to get information, whatever they see that information, you can either agree that the post might be right to you or it might be wrong, and then you write whatever very nicely. Hopefully, I don't think, or probably a comment like, I don't think this is what you are saying. You shed more light on that particular topic. Whatever comments any user wants to write, anyway, that's just the point I'm trying to make. So this comment is being sent back to the website's database. Now, if the comments are not being validated or checked by the engineers, by the backend engineers, or whoever is receiving it on the database, and it's being sent back, these purpose and the comments are being sent back. Let's say another user comes online, comments, or maybe it was one who wrote the blog and he wants to see how people are reacting to the blog. So the comments that are sent by other users are displayed on his phone from via the HTTP request. Once they are sent back to the user and they're displayed on his phone via the HTTP request. And if this, since it's from an untrusted source, no one knows who was sending the comments, whether it was a troll, whether it was a robot. If the comments are not being validated before they are presented to the user, a malicious script may have also been sent by a mischievous user back to that user. And all the user has to do is encounter that malicious script, and the script just automatically runs and collects whatever information it wants to collect from the gift. And the mischievous user, the mischievous user collects whatever information he wants to collect from the user that is unfortunate enough to meet that attack. So this particular attack, the stored XSS, is a bit critical because the user has to be logged in, and once the user is logged in, his personal details might probably be there, personal information, banking transaction, banking details, or the user can even be empty. Attacker can even make purchases with the user's details. Okay, why is it? I don't know if you guys are. I'm trying my best to break it down.
Who's ready? One. It's not hard, don't worry, it's not hard. I just need the first person that would come out like So please. Who can say it like 7 times? I can who would like to come out? Okay. Sweetness, salty, sweet. Problem. Big friend. Who would like to come out? Nobody. Okay, I'll pick my team. Find you. I just want myself in you.
You can carry me. Oh.
Let's another one. Let's another one. All right. Here this one. Will you pay attention? Will you? Ruby Rabbit recursively run Ruby routine. Ruby Rabbit recursively run Ruby routine. You can't. Come. We have a by the house. Yeah, come. Real quick. Yeah, go. Ruby. Right, this is not one, right? Ruby Rabbit recursively run Ruby routine.
Ruby Rabbit recursively run Ruby routine. Ruby Rabbit recursively run Ruby routine. Ruby Rabbit recursively run Ruby routine. Ruby Rabbit recursively run Ruby routine. Ruby Rabbit.
So that's one yourself a gift. So after you should meet gifts and children.
No, not now.
Right, so just meet me later on, right? Again, the guy that won the answer the first question. Somebody won the first question. The last speaker before Elizabeth. Just nobody. Give everyone that one.
Okay, we talked at the stored XSS attacks. Then the third one is the DOM-based attacks, and the DOM-based attacks, the DOM-based XSS attacks, and this happens more on the client side. So in a situation where data on the client side is being delivered in an unsafe way, and it's being used on any other parts of the DOM, an attacker can construct or can send in a malicious script via this DOM. All I'm saying is in in a situation where probably in an app where you have to like enter a value into an input field, and then that value is being sent still on the client side, so another part of the DOM, so an element in the HTML. So an element, am I the one shaking it? Okay, I don't think so. And it's being sent to another part of the input field. There is these manipulations that are happening there. An attacker can send in a malicious script via that field and cause the scripts to run and get whatever information they want to get. Impact of this cross-site scripting vulnerabilities, like I said earlier, in a simple application, all the users are anonymous. The impact might be minimal because there are no personal information from the users. Well, in an application that is holding sensitive data like bank transactions, emails, healthcare records, the impact might be serious. Now, in a situation where the user has privileges, has some special access to the site, maybe authorized privileges, or probably whatever happens, the user is an admin and he affects other users, probably the consumers or just regular users. If the admin of that app is attacked, the situation can be very critical because a lot of users' data are going to be taken. Okay, cross-site request for your attack. This is similar to inviting a friend to your home and the friend comes to your house. You take the friend to your room. I know there are some of us that have really close friends that we bring to our bedroom. Leave the friend for a while, probably to get him a drink or something, and then the friend goes into your bag to steal some money without you knowing. That is what this attack is like. So it's a security vulnerability that occurs when an attacker tricks a user into unknowingly executing actions on a web application without their consent. Now, if the user is being authenticated on a web app or a website, and attacker has access to that user's account already, the Java's database will not be able to differentiate the request that is being made by the user is coming from the attacker or the user. So it won't be able to differentiate if it's a forged request or if it's an original request. So the attacker can send a request back to the database, make purchases or something, and then the server approves of it because it's not able to differentiate who he's sending the particular request. The third type of security vulnerability is the injection attacks. And this occurs when an attacker injects malicious code into an application or a system, often through input fields or data entry points. Let's say you're a chef that cooks for really distinguished guests, and you have this particular recipe you follow because everyone has tasted that particular meal you prepared and they like it, gotten a lot of complaints from it. So there's this particular step you follow, and someone just comes in, probably someone that is really jealous of you, comes into your kitchen and probably a toxic is a toxic ingredient. And then that way, and then the meal turns out bad, very bad. That's injection attack. There's the code injection. This type of injection attacks happens when the script is written in the same language that is brought. There's the carriage run and line feed injection attack. There is also the injection. Sorry, about the carriage return and line feed injection.